Good day, everyone, especially my students. I welcome you to Lagos State E-Science Practical class. My team and I, Oduso Atolokpe Joseph, a Lagos State chemistry team, will be taking you through a three peculiar topic that you will need when you are writing your WASEC exam. The first one is the laboratory apparatus and the experimentation. And the second one is the rate of chemical reaction, which I'm promising you is going to be more practical oriented. And the last one will be identification of gas or gases and the anions. You remember we cannot do this by just talking, so we have to walk down to the lab and let's start doing experiments.
E-Science Practicals, achieving success in science subjects.
Welcome back, my students. I welcome you again to Lagos State E-Science Practical class. I'm still your instructor, Atolokpe Joseph Oduso. So we shall continue from where we stopped in our previous lesson. Can you remind me what we did? Okay, I heard you saying test for what? Oh, somebody mentioned HCl gas. No. Oh, another one say alkaline gas. Oh, correct. But you need to be more specific. What? Ammonia what? Gas. So we are going to continue from there. Thank you for your listening. So what we are going to be doing, we're told to divide the solution into two equal parts, which is what we've done. You see a solution what? C. So this is the second part of what? Solution C. So in this solution, we are told to add silver triazonitrate 5. But before we do that, you remember what you need to do? I've told you, before you write, you have to write your test. Then when you are doing your experiment, you need to write your what? Observation. Then complete it with your what? Inference. So it's very, very what? Key to your exam. So I have C solution. So I have C solution now plus AgNO3 aqueous. For you to score, you have to put C solution. It's no more C. Or C aqueous is allowed. And you have to indicate the state of matter of that particular salt. Silver what? Nitrate aqueous. So what will happen when we add AgNO3 to it? So we have to look for where the AgNO3 is. So this is the AgNO3. Just a few drops. So I'm adding AgNO3 to my solution C. Okay, fine. What do you see? White what? Precipitate. Yes. If you have watched our video on laboratory apparatus, your teacher have taught you what a precipitate is. Now you can comprehend it to what we are doing in the lab now. So this is a precipitate. And what is the color of this precipitate? Is it white? Let me hear you. Oh, yellow. It doesn't look like yellow. This white precipitate. So I have to make what? I have to make my observation. Yes. White precipitate is formed. I need to write my inference. What are those anions that have color called white? So we have SO3 2 minus, or CO3 2 minus, or Cl minus is present. Do you remember that any wrong anions you give, they will deduct your mark? So if you put one wrong anions, you have minus half. If you put 2, you have another minus 1. So if you don't remember, if it's the only one you remember, just put 1 and get your mark and go. Is that clear? Can I hear you saying that? Okay, fine. Good. So the next question is, we are told to add HNO3 dilute. So I will come here and put plus HNO3. This triazonitrate 5 acid dilutes. Yeah, I want to see what's going to happen when AgNO3 is added to this solution. You have to gently look for your HNO3. So this is your HNO3. So add gently to see what will be the effect. So I discovered that no effects of HNO3 dilute on the resulting solution. So what am I going to write here? Say white precipitate, insoluble. Yes, white precipitate what? Insoluble. And don't forget, 1 mark. Then this 1 mark. So out of these anions that you've mentioned before, it is only chlorine ion that is insoluble in HNO3. So here we expect you to put Cl minus is present. Do you still remember what I told you earlier? That any wrong word, inference, attracts negative mark. So you need to be sure of your cations or your anions that you are putting under your words, inference. The confirmatory test for this chloride ion is by adding what I called NH3 aqueous or aqueous ammonia. So you have to look for it. The labeling is very essential. So I have it here. What I need to do now is to add aqueous ammonia to this solution to see if the white precipitate will become soluble or not. So let's do that together. Are you watching me? Please watch me closely as I add it. Okay, fine. So what do you see? You discover that the white precipitate has become colorless. So I need to what? Report my observation. So to do that, I will say plus NH3 aqueous. So we call it aqueous what? Ammonia. So what happened to the white precipitate? As you can see here, white precipitate soluble. So white precipitate is what? Soluble. So what will be my inference? Cl minus is confirmed. It's very, very essential at this particular point. So let me recap from our learning objective. You remember when we started, I said, we as a student be able to what? To record our what? Observations. This is what we've done by putting test, observation, and inference. And the second learning objective is we'll be able to what? Identify any gas or gases involved. So the gas we're able to identify from this experiment is alkaline gas. So we call it what? Ammonia gas. And lastly, we must be able to what? State the conclusion drawn from the results of each test. So from this particular test, we were able to identify ammonia gas and the chloride ion. I hope you've understood it from a given question. Now, for you to have a better understanding of what I've taught you today, you have to go back to the school, meet your subject teacher, your chemistry teacher, and try to replicate what I've done. If you have any comments, any question, don't hesitate to ask me. I'm your instructor, Tolulope Joseph Odusa. Bye for now.